everybody, welcome back boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, we're going to be wrapping up that unit number 8, finalizing our ideas on that Pythagorean theorem, and talking about those rational versus irrational numbers. So in the number 1, it says, which of the following is not a right triangle? So what I'm going to do is I'm going to break this apart, and I'm going to do and prove. So prove using Pythagorean theorem. And what you need to do is you need to say, well, okay, I have a squared plus b squared equals c squared, but I need to make sure that, out of those three side lengths, because I don't see a right angle, because that's what we're trying to prove, is if this is a right triangle or not. We have to say, well, I know that 10 is the largest, and so I can write it like this. Write your values in order from least to greatest. So write values in order from least to greatest. That way, when you are plugging them into your formula, it's a little bit easier to see. So for example, I would say this is 6 squared plus 8 squared. I'm saying, is this equal to? So I need a question mark on that equal sign. I'm saying, is this equal to c squared, which is 10 squared? Multiply those out. Again, use that Desmos calculator for yourself. So let me pull that up. In that Desmos calculator, type in what you have. So I hit the little keyboard button to bring up your options. I'm going to say I have 6 squared, I have 8 squared, and then I have 10 squared. And so I need to say, do these two add up to be 100? And so I'd say, is 36 plus 64 equal to 100? And we would say it absolutely is. So make sure you can use that Desmos calculator for yourself, making sure that you are squaring those numbers or raising them to the exponent of 2. So I'm going to say like this. I have, this is going to be 36 plus 64 equals 100. I would say 100 equals 100. So this is a right triangle, and so we're going to say it's not a, because we're looking for not a right triangle. Moving on to my next one, I'm going to say let's do a different color. Let's do blue. So now for this part C, I have 5 squared plus 12 squared. Is that equal to, so question mark, is that equal to 13 squared? Make sure you know your perfect squares. So 5 times itself is 25. 12 times itself is 144. 144. And 13 times itself is 169. Add these two together. I have 169 is equal to 169, which this means it is a right triangle. So I know it's not C. So I can cross C off. Moving on to the next one. Let's say for D, if I have 3 squared plus 4 squared, is that equal to 5 squared? Let's find out. So this is 9, this is 16, this is 25. And that means that this together is 25, and so I have 25 equals 25. So that one is a right triangle, which means we are not going to pick it either. So only option left is B, and so I'm going to show B down here. So let's do that option number B. So let's say 3 squared plus 4 squared, is that equal to 7 squared? And so what we can do is we can say, well, I have 9 plus 16, is that equal to 49. We're going to say no because 25 is not equal to 49. So this is going to be the one that is not a right triangle is B. So not a right triangle. All right. So make sure you're using that Pythagorean theorem to prove whether three side lengths are a right triangle. For number 2, it says plot the following numbers on the number line. And so it has a couple square roots. And so what you're going to do is this. So I'm going to pull that Desmos calculator back up. Let me clear some of those numbers out. Clear these out. So again, find that bottom left, that little keypad button, and I'm going to be using the square root symbol now. So I'm going to say square root of 3. I have square root of 6. I have to have the square root of 4, square root of 9, square root of 13, and lastly, square root of 25. So find each of those square roots, and you want to order these from least to greatest. And notice how, for 3 of them it has whole numbers, and 3 of them it has decimals. So make sure you're taking those decimals and placing them on the number line. So for example, let me actually do it like this. Let me see if I can cut this part off like this, and then move this over here, so that way we can write some of these down. So I'm going to say, I'm going to have square root of 3 was 1.73. So let's say square root of 3, let me write these down. So square root of 3 is about 1.73. I have square root of 6 is about 2.44. Square root of 6 is about 2.44. I have square root of 4 is equal to 2. Square root of 9 is equal to 3. Square root of 13, 3.6. Square root of 13 is equal to, what do I say, 3.6? 3.6, about approximately. And then this is going to be square root of 25 is equal to 5. So make sure you can write those down first, or if you need to, write them on the side, you certainly can. And now I'm going to say, so let me fix this, do undo, and let me hide that again. All right, so let's place these numbers on the number line. Again, make sure you can say, remind yourself, if I'm saying, well, is it going to be, closer to 2 or closer to 1? Well, I know that in the middle is going to be that 1.5, and so I should be to the right of it. So make sure you're just plotting those points on the number line. So I'm going to say, let's say about right here is going to be that square root of 3. Our square root of 6 is going to be in between 2 and 3. So I'm going to say about right here is going to be square root of 6. Square root of 2, that's going to be on 2. So I can say that's going to be square root of 4 is directly on 2. Square root of 9 is going to be directly on 3. So I say this is square root of 9. Square root of 13 is in between 3 and 4. So let's have it be about right here. That's going to be square root of 13. And lastly, but certainly not leastly, we're going to have our square root of 25 is on 5. So make sure you're saying, if it's exactly a number, like square root of 4, square root of 9, square root of 25, it's going to be a perfect square, and it has to be directly on those points. For number 3, it says find the length of the segment that joins negative 7, negative 5, and the other point is 6, 1. So let's plot those points out. So I'm going to go 7 steps to the left and 5 steps down, plot my point. For the next point, I go 6 steps to the right and 1 step up. And so I can find and say, okay, well, my line segment is this. So I'm finding this purple, or you can even say, pink, whatever you want to call it, line segment. But what I need to do is I can draw this right triangle that is in between these points. So I can say, let's say, what is this green amount? So what's this green amount? And what is, let's do red. What's going to be this red amount? And so I can say, well, how long is this side length? Well, this side length here, I go from 1 to -5, so this is going to be 6 steps. And from -7 to +6, that's going to be 13. So the green part, this green part is going to be 13. And what I'm trying to find, you can notice how it makes a right triangle. And so I'm trying to find this purple length, which is that side length C. So I know, hypotenuse, so again, hypotenuse is the longest side. So when I'm looking at my answer, I should have an answer that's going to be greater than 13 and greater than 6. That means out of these three sides, I have to have the largest side on that diagonal. I'm going to use that Pythagorean theorem, so I'm going to say I have a squared plus b squared equals c squared. I'm solving for my side length c, so I'm going to have, I have 6 squared, I have plus 13 squared is equal to c squared. So make sure you can multiply carefully. I do 6 times 6 is going to be 36. I have 13 times 13 is 169. I have this is equal to c squared. Add these two together. So I'm going to say it's going to be, what was that, 190 and 205, 205. Always double check if you need to. Let me clear some of these out. 205. See it in here. Or sorry, 169. Yeah. Okay, so now I have to take that square root. So let me actually show you what I'm looking at here. I take that square root, so I'm going to hit enter. I say click on the keypad, square root 205, and so I'm going to say it's going to be about 14.31. So let me hide this again. Say, okay, so this is going to be equal to c squared. Take the square root, so take the square root of both sides. And so I can say c, we have purple, I'm going to say that side length c is going to be equal to the square root of 205, which is equal to, or approximately, what did I say, 14.31, triple check one more time, yeah. So as long as you have, if you want to leave it in that form, you can, or if you want to have the decimal value, make sure you're evaluating carefully. For number 4, it says Mai's younger brother tells her that 10 over 7 is equal to the square root of 2. Mai knows that this can't be right because 10 over 7 is rational and square root of 2 is irrational. Write an explanation that could be used to convince her brother that 10 over 7 cannot be a square root of 2. So you could say it's something like this. So we can say, well, when we are thinking about the square root of 2, we would have to say that we're looking for solution of this. We're saying, x squared equals 2. So whatever our solution is, we have to say our x is going to be that square root of 2. So we're saying 10 over 7 is not equal to the square root of 2, since 10 over 7 is not a solution to the equation x squared equals just 2. So since it's not a solution to it, meaning if I look at it like this, I can do 10 over 7 squared is the same as 100 over 49, which is equal to 2.0408 with values after it, which if I notice, hey, that's not exactly 2. So when I square this number, I have to have it equals exactly 2, which it does not. So that's why it is not equal to it. For number 5, it says calculate the missing side length of this right triangle and round to the nearest tenth. So what we're going to do, use that Pythagorean theorem. It gives us a right triangle, so we know it's already like that. So what I can do is I can say across from or opposite of my right angle is my hypotenuse. So I'm going to say this is my hypotenuse, which is my side length C. So that means when I use my formula, I'm going to say a squared plus b squared equals c squared. Plug in my values. So I'm going to say I have, let's let that be a. So I have x squared plus 18 squared is equal to 24 squared. Again, be mindful where you plug those in. I have to have that side length c is going to be where the hypotenuse is. Make sure you can multiply it out. So I'm going to say like this. Let me pull up our wonderful Desmos calculator. I'm going to say I have 18 squared, I have 24 squared, and I need to subtract both sides. So I'm going to say 576 minus 324 gives me 252. And then I take the square root. So I say the square root of 252 is going to be that amount. What you can do is, if I need to round to the 10th, is that what it is? Round to the 100th. So then I hit enter. I click on my number, Control C to copy it. I say, okay, I need to round it. So I need to round. And I say, paste my number in. I hit comma 2, and it'll round it to the second decimal place. So make sure, again, you're rounding to the second decimal place for this. So let's take those steps one at a time. So let me get these numbers down. So I said like this. If I can find, there it is. So we're saying 18 squared. So I still have x squared. 18 squared is 324. 324. 24 squared is 576. Triple check one more time. Yep, 576. Now I have to subtract both sides because I'm trying to get x by itself. So I subtract 324 from both sides. So I have x squared equals 252. Last step, take the square root of both sides. And I know it's not equal to 252 because my answer has to be less than 24. So take a square root. I can say I have x is going to be equal to, and we rounded and we said it, we have 15, or what did we say? Yeah, 15.87. 15.87. So be sure to round the nearest hundredth. That means second decimal place. And lastly, we're going to calculate the diagonal length of the rectangular prism. So we're going to be finding this blue length. So we did this in the previous lesson. So if you need to check how to do that, I already kind of did it there, but I'll do it again one more time. So what I'm going to do first is I'm actually going to find this side length in purple. I need to cut across the bottom part like this, and so I need to draw my right triangle, and I'll say, my purple side length is what we're going to find first. So I'm going to say this is 5 and this is 12, and let's call this a side length C. So I plug it in my formula. I have I have 5 squared. Let me make sure we have it. So I have a squared plus b squared equals c squared. My two side lengths are like this. I'm going to say I have 5 squared plus 12 squared is going to be equal to c squared. So that's what we're looking for. Make sure you can multiply that out. So I have 25, 144 is equal to c squared. Add these two together. This is going to be 169, which is c squared. Take a square root to get c by itself. So I say 13 is actually equal to c. So let me do that in purple. So let's say 13 is equal to c. Be careful not to circle that as your answer because we're saying, hey, this side length is 13. We need to find this blue side length. Make sure you remember, though, that, again, the opposite sides on this prism are equal, so this is going to be 17. And so what I can do is draw it like this. I'm going to be looking for this diagonal length in blue. Let's let that be x. I have my purple bottom length, which is 13. And I have my height, which is 17. And so now I need to do those same steps, and I can say what my value is. So I'm going to say if I have a squared plus, let me move this up a little bit. I have a squared plus b squared equals c squared. Plug in my values that I am looking for. So I have 13 squared plus 17 squared is equal to x squared. And so then we find these lengths. I have 13 squared is 169. Pretty sure that's 289, but let me double check. So we said, let me clear these out real quick. Let's do 17 squared is 289, yep. Plus 289 is equal to x squared. I need to add these two together. So I need to add a 169 to it. 69. So there we go. 458. So 458 equals x squared. Take that square root. So we say, I do square root of 458 is going to be about 21.4. So we're going to say, let me do it in blue. I'm going to say x is going to be about 24. Is that what we said? 21? No, sorry, 21. 21.4. And that makes sense because it should have been the longest of these three sides in that right triangle. So make sure you're seeing how that works. Make sure you can pause, rewind, replay as needed. And as always, super slam that subscribe button.